Vanakkam. Now we are going to solve problem number 2.77 from Fundamentals of Electric Circuits by Alexander and Syracuse 5th edition. It's an engineering design problem. Okay. Suppose your circuit laboratory has the following resistances available in large numbers. But you have to design some other circuit which needs only particular value of resistance. For example, here you need to have 5 ohm resistance. But availability is what? Only 1.8 ohm, 20 ohm, 300 ohm, 24 kilo ohm, 56 kilo ohm. With this available resistance, you have to make up this 5 ohm resistance. So how do you do that? So for that, we very well know that large value of resistance like this 20 ohm. Okay. And if you want to get small value from this large value, then you have to go for parallel combination. So if you do the parallel combination with the two 20 ohm resistances, you will be getting 10 ohm only. So one more 10 ohm is required, isn't it? Then only if you put parallel combination for that, then you'll get 5 ohm resistance. So in order to get this 10 ohm, again you go for another two number of 20 ohm resistances in parallel. Okay, so in total we need 4, and then you have to connect them in parallel like this. Then this combination of 20 ohms is actually equivalent to how much? It is 5 ohms. Okay, so now we go for the second case. We want to make up this 311.8 ohms. So then we search for the availability. So we know very well that this 300 is there, or we can take one 300 ohms resistance plus, because it can be written actually 300 plus 10 plus 1.8 will give you 311.8 ohms. This is what we require. So this is available. This 1.8 is also directly available, but this 10 ohm resistance is not available. So that we have to make it from the available resistance. Already we know that this can be formed with the help of this 20 ohm resistances in parallel. Two numbers we require. One number of 300 ohm resistance will take, and one number of 1.8 ohm resistance will take, and will take two number of 20 ohm resistances in order to form 311.8. But how do you actually do it? This 300 in series with this 1.8, this is how we designed actually. Okay, then here you should have this 10. Okay, for 10 what you do, this 20 ohm resistances will be connected in parallel. So when you measure this value, the resistance value, that will give you 311.8 ohms. So this is your answer for the B case. Then we move on to the third. So here we need to obtain this 40 kilo ohm, right? So how to get this 40 kilo ohm? So it's very simple. Is that so? It's not 40 ohms, it is 40 kilo ohms. So in terms of kilo ohms, we have to check these two resistances are available. So with the help of this kilo ohm resistances only, we have to make up, or we have to obtain this 40 kilo ohm resistance. Okay, fine. So if you put 24 in parallel with the 24 kilo ohms, right? This is kilo ohms. So you'll get 12 kilo ohms. Similarly, go for the other option, 56 in parallel with 56 kilo ohms. So there you will get 28, the half, right? So 28 kilo ohm. So when you add these two, 12 kilo ohm and 28 kilo ohm, you will get the value as 40 kilo ohm. Okay, fine. Then we'll get this answer. So how many number actually we need for this? So this is one number of 24. This is second. Okay, so we need two numbers of this 24 kilo ohm resistances. Similarly, we need 1 and 2. Okay, two numbers of this 56 kilo ohm resistances. But how would you actually make it to get this? These two must be in parallel, right? How you need to connect 24 kilo ohm and 24 kilo ohms in parallel, that will give you 12 kilo ohms effect, right? Similarly, then you take here, and here you connect 56 kilo ohm, another 56 kilo ohm in parallel, so that it will give you the effect of 28 kilo ohms. So across these 2 points, this will give you 12 This will give you 12 kilo ohm effect and this will give you 28 kilo ohm effect, and these two must be connected in series like this. Okay, so across this, if you measure the resistance value 40 kilo ohms. So this is how actually we have to give the connection. Okay, this is for the third case. So now we move on to the fourth case, that is D. It is 52.32 kilo ohms. Again, first you take this as 52 plus zero point 0.3 kilo ohms, 52 kilo ohms as well as this zero point 0.2 kilo ohms. First we'll look at this 0.32 kilo ohms. So that can be actually written as 320 ohms. So 320 ohms means here we can get it from these two combinations, right? So how do you get it? This can be obtained using this 300 plus 20 ohms resistance. So one number of 300 ohm resistance you take, another one number of 20 ohm resistance you take. When you connect them in series, then you will get this 320. That's okay. So now how would you form this 52 kilo ohm? So we'll take two number of 56 kilo ohm resistances in parallel, as already we have seen. So that gives you 28 kilo ohms, right? So this 28 along with this 124 kilo ohm, if you take, this is also available. So that makes you sense, right? Okay, fine. One number of 300 ohm resistance you have to take, and one number of 20 ohm resistance you need to take, and then two numbers of this 56 kilo ohms we have to take, which are to be connected in parallel, and that combination is to be joined with this 24 kilo ohms. So that is one number. But how the connection would be actually? So this 300, this is 20 ohms, they are connected in series, then only they will get add up, right? If you see this plus sign, just the series connection. Then 56, 56, they are in parallel, right? How do you make it up? Like this, you have to put, you have to join them like this. This is 56 kilo ohm, here also it is 56 kilo ohm. Then to this point you need to connect this 24 kilo ohm. That's it. If you suppose it, take it as A and B, and if you measure the resistance value across this, then you will get the value of 52.32 kilo ohm. 52.32 kilo ohms. This is right here. So answer is this one. Okay, that's it. Okay, thank you. Hope you have understood.